Hi students, it's your friendly science teacher here. This is going to serve as an introduction to minerals. Now, the very first question you might ask yourself is, well, what is a mineral? Well, if you look at these pictures, how can you tell which of these are minerals and which ones aren't? Can you tell just by looking? I don't know. I'll give you a hint. 3 of them are minerals, and 3 of them are actually rocks. Minerals have 5 characteristics. They are naturally occurring. They are inorganic, they are solids, they have a definite chemical composition. What that means, they're made of the same stuff in the same ratios every time. Now, the 2 most abundant elements that make up Earth are silicon and oxygen. And the way that these combine will give you a different mineral. So sometimes you could have Si2O3, or sometimes you might have Si3O2. Those are different proportions, which are different chemical compositions, which would be different minerals. The last characteristics that minerals have is that they have a specific crystal structure. That means that these atoms are arranged in a certain way to give them a certain shape. How are minerals identified? So if you find a mineral out in the field, how are you going to be able to tell what it is? There are a set of tests that scientists use to determine the identity of a mineral. The first one is color. Now, sometimes color can tell you right away what mineral it is. For example, this very yellow mineral right here is the mineral sulfur. We know because it has a very distinct yellow color. But color is not an obvious feature. Over time, minerals can change color with exposure to air or water. For example, the Statue of Liberty was first coated with a copper finish. But over time, with the moisture in the air and the oxygen, the copper has been oxidized to this really weird green color. You also cannot use color as a sole indicator because sometimes minerals might have more than one color. For example, the mineral quartz can be found in up to 8 or 9 different colors. So more tests are required to identify a mineral. The next quality is luster. This describes the quality of light that's reflected from a mineral surface. We describe the luster in 2 ways. The first way is metallic. This would be the appearance of metals. Often it gives you a shiny look. The other way is non-metallic. Non-metallic is a little bit less precise because it could look glassy, pearly, silky, dull, or sometimes earthy. We can also use a mineral streak. The streak is the color that's left behind in its powdered state. We use a porcelain streak plate to perform this test. For example, this is the mineral hematite. When you take hematite and you run it across a porcelain plate, you will get a red-brown streak. Streak is a better way to identify your mineral than color is. For example, these 2 minerals, one of them is gold, one of them is fool's gold. Can you tell the difference simply by looking? Probably not. But you can see that after running these across a streak plate, their streaks are very different. Pyrite gives you a much darker streak than gold does. The next property we use to identify minerals is a property of hardness. This is an example of how easily a mineral can be scratched. The scale that we use is called Mohs hardness scale after the scientist Mohs. We use values of 1 to 10. 1 is the softest mineral. This is talc. You can easily scratch talc with your fingernail. Most of the time when you find talc, it'll be in substances like baby powder. Diamonds are the hardest mineral. Only a diamond can scratch a diamond. The arrangement of atoms in the mineral usually determines the hardness. This is the way that you can determine the hardness of a mineral in a lab. If your fingernail can scratch the mineral, then we say it's less than 2.5. If your fingernail cannot scratch the mineral, we know it must be harder than your fingernail. So then you would scratch it across a glass plate. If it does not scratch the glass plate, then we know it has to be softer than 5.5. If the mineral can scratch the glass, then it's harder than 5.5. Lastly, each mineral has its own unique density because each mineral has its own unique chemical composition. Just as a review, density is the mass divided by the volume. You can find the mass using a scale or a balance. You can find the volume by water displacement. Then you can divide. You can compare the density of two mineral samples of approximately the same size to get an accurate representation of density. Another way that we can identify our minerals is by cleavage or fracture. This is the way a mineral breaks, and it can tell us quite a bit about its structure. Minerals that break along a smooth, flat surface have what we call cleavage. Minerals that break with jagged or irregular edges are fracture. Your mineral will either have cleavage if it breaks evenly, or it will exhibit fracture if it breaks unevenly. Take a look at the diagram here. Sometimes minerals will cleavage in one direction, so they will tear off like sheets of paper. Example, muscovite will tear off like sheets of paper. Sometimes you can see cleavage in two directions. You can clearly see that this breaks in a regular, even pattern. Like feldspar and also calcite will have cleavage in two directions because you can clearly see these flat planes or edges. Halite will exhibit cleavage in three directions because it could break in one of three ways. Sometimes minerals will have special properties, such as taste or smell. Some of them might taste salty, like halite, but we are never going to taste the minerals in our lab. Some minerals have a very distinct feel to them. They could be slippery or they could be greasy. Also, some minerals will react with an acid. We can do a test called the hydrochloric acid test to find out if our mineral is made of something called carbonate. Here is a picture of a mineral reacting to hydrochloric acid. The carbonate reacts with the hydrochloric acid and carbon dioxide is created. That's where the bubbles are coming in. That's all we're going to have time for today. Thank you.